right. Well, our last lesson, we just went through the differences between inverses. And we talked about additive inverses, multiplicative, and functional inverses. And we said functional, which we're really going to be focusing on, is you get that when you compose two functions together and you get the input. All right. Then once again, you get the input. Okay. Well, another thing when we talk about functional inverses is that we're going to dive now in this tutorial about how to identify functional inverses and go through the properties of functional inverses besides just decomposition, algebraic property. Because there are definitely some important parts. Now, the first, I always think of this when I think of functional inverses. I think that they have two rules. Two rules. All right? I always think of Fight Club when I hear that, Fight Club. All right, Fight Club. But this is not Fight Club, but, all right, Function Club. Or Inverse Club, I should say. Inverse Function Club. Yeah, now I'm just changing everything. Function Club. And if you remember about Fight Club, there's like two rules in Fight Club. First rule is don't talk about Fight Club. Second rule is don't talk about Fight Club. Well, when I think of functional inverse club, all right, there are two rules, okay, two rules, all right, and they kind of go back and back, but it's like, first rule, not all functions have inverses. That's the first thing. Not all functions have functional inverses, okay, not all of them. And only, which ones do? Only one-to-one or monotonic. Monotonic, all right, monotonic functions have inverses, all right. What does one-to-one mean? That's the kind of an important thing. When you talk about one-to-oneness, all right, one-to-one refers to, all right, first off, with a function definition, all right, is that what we have is for functions, every input has one output. Now, so first off, the first thing is that in order to be one-to-one, you have to have a function. Okay, so the definition of function, every input has one output. All right, that's true. Now, the converse of that statement also has to be true if it's going to be one-to-one. Every output has to have, all right, one input. Okay, one-to-one relationship. Every input has one output, and every output has one input. That is what one-to-one means, and that's what monotonic means. Mono meaning one. Monotonic means every input has one output. So, how can you identify if you have a monotonic one-to-one function? Okay, what is one-to-one? Every input has one output, and for every output there's one input. There we have it. And how can you identify this? Well, you take a graph. Okay, so if you have this graph, I start with an easy one. Lines are what we call one-to-one. They are always one-to-one, and are very easy to find inverses of. This is what you probably started if you were in advanced algebra, or algebra 1 or algebra 2, probably what you talked about. And this is what we talk about in pre-calculus as well, is that when you have a line, okay, you can graph it. We have a y-intercept of -3, so I'm going to just plot this, -3. Bing. All right, we got rise of 2, and it's our slope. All right, slope. Now I'm removing lines. All right, y-intercept. Okay, you can just plug zeros in there. Find 2 points. All right, 1, 2 over 1, and we have this other point. Connect the dots, blah, blah, and we find our, all right, inverse. Or we find our function. Now, this function is a function. We know that because the vertical line test. Apologize about that. The vertical line test tests to see if you have a function. So if you drew a vertical line, and let me get a vertical line here. There we go. So if I drew this vertical line, and I'll make this one like that. So here's my vertical line, like that. And if I drew this around here, and I placed it anywhere here, I would only hit 1 point. All right, and I do. Okay, and you think about this goes on forever, but that's what we got. Now, that tests for a function. The horizontal line test, once this test is done, now we go to the second part. All right, for every input, one output, check. Second rule for one-to-one, every output has one input. That's where we go to the horizontal line test. So if I take this now and I turn it around like that, and that's horizontal, and I take this graph, and now I place it, and I only hit 1 point, okay, which I do. Now it is one-to-one. The horizontal line test tests to make sure that you have an inverse, the functional inverse, or it's possible to have a functional inverse. Okay, that's where students sometimes get screwed up. all right, is that these two tests together test for one-to-oneness. So together, their properties combined test for one-to-oneness. Okay, that's a line from Captain Planet, if you didn't know. Okay, all right, so this is a function. It is one-to-one. Because it is one-to-one, all right, what we can do now is we can actually find, all right, its inverse. So the next thing we're going to do is let's find the inverse of this function. Okay? Now, how do you find the inverse of this function? Well, to find the inverse, you first, so now we're going to find the inverse. Now, because it has an inverse, we're going to actually find the inverse of this function. Okay? To find this inverse, all right, is that we're going to take our value, our function, and the first step is we're going to write it as x and y. Okay, so first step, step one, all right, make it x and y's. Okay, so get rid of this f of x, change it to what it is equivalent to, which is y. All right, so change into x and y. And you can't read that at all. I can't even barely read it. All right, into x and y. So that's the first step. Now, once we get that, the next step, in step 2, is because, all right, we're kind of taking the opposites, and we want to have that composition, we're going to switch the x and y values. Switch the x and y values. Now, in my class, I usually have a thing, and I go take my arms, and you can't see it because it's not a video tutorial. And I wish I had a video of me doing this, but I don't. But you switch. Maybe you can just switch the x and y's. Emphasize the switch part. All right, x and y values. That's how you do the inverses. So I'm going to have x equals 2y minus 3. X equals 2y minus 3. And now, after you have that, the final step, step 3, is we're going to solve for y. So once we switch them, we're going to go to step 3. All right, I really should make this in color-coded. That would be nice, huh? We'll make that green. Okay. And there we go. All right, and now the last step, and we'll have this one. Step 3, solve for y. Okay, so make it an x and y, switch x and y values, and now solve for y. Now here when we solve for y, it's pretty simple, basic equation. We have this, and we divide by 2, so we have x plus 3 divided by 2, that's a 3, equals y. And this is what we call our inverse. Now, this is some weird notation that you will see. All right, you have f with this little negative. Doesn't mean reciprocal, even though a lot of students think it is. This actually means inverse. That's all it is. All right, it's inverse function notation. Just like when we have the negatives and the -1 for the exponent, that means the reciprocal. They use this notation when you deal with inverses. Okay, it's just notation for inverse. But that's our inverse. This is it right here. Just to make sure, all right, we can test this, all right, right here, algebraically by plugging in f composed of its inverse. And this is how we write it. Composed of its inverse like this, and we're hoping to get x. So we have 2. I'm going to take my inverse I found, x plus 3 over 2, plug it in there, minus 3. And I'm praying that I get the right values. Simplify, get my red cancellation. Cancel, cancel. Now we're left with x plus 3 minus 3. We have that. Once again, these cancel. And what we're left with is x. Hey, what do you know? Our test for inverses, all right, right here, all right, for inverses works out. Okay? And that we got x, and we know that these two are inverses of each other. All right. In our next tutorial, we're going to go through some more properties of inverses and through some more examples. But I hope this helps out on how to find inverses and how to test one-to-oneness and using the horizontal vertical line test.